We're talking about triangles again. We mentioned this yesterday, but we didn't officially talk about this, right? It wasn't official, but now it's going to be official. About the angles inside the triangle, okay? Or the measure of the angles inside the triangle. And I say the measures of is talking about the number, how many degrees. When you talk about an angle, you're talking about how many degrees. And we've talked about this before. If I had, let's just put A, B, and C. So if I add up angle A plus angle B plus angle C, the measures of those angles, how many degrees is that going to be? It's going to be 180 degrees. And you probably learned that before. All right? Has anybody ever showed you why that's true?
Yeah, earlier when we did a couple lessons.
I doubt it. No, because we haven't talked about this except for yesterday, and we didn't say why that was true. Let me just do one quick little thing. No, we didn't really say why it's equal to 180. We said why you can't have two obtuse angles and why you can't have two right angles in a triangle, that kind of stuff. But we never did talk about why it's 180. I mean, how do you know it's 180? Just because it is?
Just hold it and then turn it into a straight line.
That's actually a decent idea, actually. All right, but let's take a look at this. This is just showing you why all three of these angles add up to 180 degrees. I'm going to label these by numbers. Is that all right? So this is angle 1, this is angle 2, this is angle 3. We'll call this angle 4, and we'll call this angle 5 down here. Now this is nothing that you're going to have to do on a homework or a test or a quiz, but I think sometimes, every once in a while, this is easy enough to see. So every once in a while, I think it's a good idea to see why this theorem is true. Okay, why do the angles add up to 180? You probably learned that back in middle school, that the angles of a triangle add up to 180. But I really doubt in middle school your teacher showed you exactly why that was true. They probably just said, this is true, you just believed it, and you went on your way. All right? And that's fine. Okay, in middle school, that's fine. But now we're in high school, now we're in geometry. There are certain times where we'll stop and we'll show you why certain things are true. Let's do this. We've learned this before. Okay, we learned that when you have a straight angle, how many degrees is a straight angle? 180. So look at angle 1, look at angle 2, and look at angle 3. By the way, this I made parallel to that. Okay, so I made that parallel to this. Well, we'll get to that in a second. Let's just take a look at angles 1, 2, and 3. So let's do it down here. So angle 1, let's not. Let's do it up here. Got a little more room. We'll do it like here. So watch. Angle 1 plus angle 2 plus angle 3 is equal to what? They form a straight line. So what do we already learn in the past about a straight angle? How many degrees? 180 degrees. Do you agree with that? All right, so that's something we already knew. Okay, by definition, a straight angle is 180 degrees. So if you have, no matter how many angles you have, if they all add up to be a straight line, which these three angles do, you know that's going to be 180 degrees. We okay with that? Now, I want you to see this. Now, I made this line parallel to this line right here. So we've learned this before. We just had this on the last test. Okay, look at angle 1. Is there anything on here that might be equal to angle 1? 4. Why 4? Because they're alternate interior angles. You got it right. Look at that. See, angle 1 and angle 4 are equal to each other because they're alternate interior angles, right? Because if I extended that side out, you get two parallel lines cut by transversal. Everybody see that? So look, angle 1 is equal to angle 4. Agreed? All right. Let's do another one. What about angle 3? Is there anything equal to angle 3? Angle 5. For what reason? Yeah, same reason. Alternate interior angles. Okay, so angle 3 and angle 5 are equal to each other. Everybody see that? So watch. Angle 1 and 4 are exactly the same. Okay, whatever, how many degrees, I don't know how many degrees it is, but whatever the degree is, the measure of this angle is, angle 4 is going to be the same thing. So watch what I can do here. I already knew this, didn't I? I already knew that these three angles add up to 180. What am I trying to show? I'm trying to show that all three angles of a triangle add up to 180 degrees. All right, so angle 1 and 4 are exactly the same. So what could I do with angle 1? Instead of calling it angle 1, what could I call it? What did we just say? We just got done saying angle 1 is equal to what? Angle 4. So instead of calling this angle 1, I could do what? Call it angle 4. That's right. I could call it angle 4. Why? Because they're equal to each other. They're the same exact angle, right? So if it's angle 1 or angle 4, it doesn't make any difference, does it? All right, so instead of calling it angle 1, I'm going to call it angle 4. Now, angle 2, that's already inside my triangle. Okay, so look, I've got angle 4 plus angle 2. Right, angle 2 is already in there, so I'm not going to rename it. Plus, I'm going to rename angle 3, though. Instead of calling this angle 3, I could call it what? Angle 5. Right, because 3 and 5 are equal to each other. Do you see that? 3 and 5 are equal to each other. So watch. If this and this are the same thing right there, of course these two are the same, these two are the same, so all three of these angles must add up to what? 180 degrees. So what did we just show? What did we just prove? We proved y, right, WHY, we proved why the three angles of a triangle add up to 180 degrees. And that was a proof. We're not going to do a whole lot of proofs in this class, okay? In the honors class we do quite a few proofs, but that was actually, it was a sketch anyway of a proof. So we actually proved that the angles of a triangle add up to 180 degrees. So you can't now say, if some teacher says, you know, was it ever proven to you, or have you ever proven that the angles of a triangle add up to 180 degrees? You can say, yeah, we did that. Okay, yeah, we did prove it, and I was shown why it was true. All right. Now, I'm not going to have this on a test. I'm not going to have it on a quiz. It doesn't mean it's not important just because it's not on a test or a quiz. I think it's important that you see why the angles add up to 180, and nobody just showed up and just said, all right, they all add up to 180, and you're like, well, okay, whatever, I'll believe it. All right, don't believe everything, all right, you're told, but if it's proven to you, you have to believe it. All right, so after this, I think you got to say, you have to believe that the three angles of any triangle, doesn't matter if it's an acute, obtuse, right, doesn't make any difference, all three angles add up to 180 degrees. All right, we got it? And you're probably thinking, you know, you told us that yesterday. Why go through all that? Because sometimes I think it's very important to show why things are true instead of just believing it. Okay, let's do another type of triangle. I tell you what, let's see. Do they have an example? Yeah, they do. They have an example. Let's do an example first, okay, before we go on to the next thing. We got this, and we got like that. And you got another one going in around there somewhere. Maybe about like that. Alright, let's put some numbers in here. And let's solve for what they ask you to solve for. So they just call this angle 1. They call this one angle 3. That's not how many degrees it is. It's just the name of the angle. Alright. This one, it's 28 degrees. So that is the measure of that angle. This one is 71 degrees. This one down here is angle 2. It's not 2 degrees. It's just called angle 2. And this one right here is 57 degrees. And I think that's it. And the question says, find all the missing angles. All right? And this is the kind of stuff that you're going to be doing on a worksheet, quiz, test. Okay? This is the kind of thing you're going to be doing. And what are we going to use? We're going to use that knowledge that we just learned, that the sum of the angles. Remember what the sum of the angles means you add up all three angles, and it's going to equal 180 degrees. So what do you think? Where do you want to start, Sean?
71 is equal to angle 1.
You don't know that because you don't know you have parallel lines. You can only use alternate interior angles if you have parallel lines, okay? Up here, see, we knew this and this were parallel to each other, so we could say alternate interior angles were equal. We know nothing about parallel angles, or parallel sides, so we can't say anything. Cookie?
You add up 57 and 71, and then you get whatever that answer is, minus 180.
That's it. Okay, watch, to find angle 2, right? Is that what you're talking about? Yep. She's going to find angle 2 first, right? Because watch what I can do. I can take 57, and you don't have to find angle 2 first, but that's what she saw. It's actually what I saw first, too, when I saw this, okay? So, look, 57 and 71, and this angle right here, which we don't know, what do all three of them add up to be? 180 degrees. So if I know two of them, what's the math to get the third one that I don't know? That's right. So it's 180, what? Minus 57 minus 71. Or you could have added them together first and then subtracted them from 180. It doesn't make any difference. I think this is a little bit better because look, if I got a calculator, shh, just listen to me. Just listen to me, okay? You're telling me I'm not even going to. I told myself today I wasn't even going to do that. So watch. 180, do it however you want to do it. I don't care, okay? I'm showing you how I would do it. Minus 71. All right, I think that's the easiest way because I don't have to do two different things in the calculator. All I got to do is just do one thing in the calculator and I'm done. It's as easy as that. And hit equals and it's 52. So that is 52. So that's what this angle is right there. That's 52 degrees. All right, so that's angle 2. We found one of them. What else can we find up here? Can I find angle 3 right away? No, because I don't know what this angle is, do I? Right? If I knew what angle 1 was, then I could find angle 3 the exact same way as I did this one. So how in the world am I going to find angle 1? Say it, Javi.
That's 52.
It's not. No, it's not equal to this. No, because we don't have any parallel lines, so we can't say it's equal to anything. Summer, what'd you say?
180 minus
How'd you get that 180? Where was that from? Because of what?
straight line.
Because of straight line. Exactly right. Look at this angle 1. Do you see that? And this angle 57. What do they form? Straight line. So they form 180, right? So we get angle 1 by setting it equal. See, we don't have any parallel lines, right? So we can't say alternate interior. We can't say corresponding. We can't do any of that. But we can look at this and say, hey, that forms a straight line. So we've done that before. That's not old. So I've got 180, okay, minus 57, all right, whatever that is. What's that, 23, 123? Is that right? So that's that angle right there. Did I do the math right? I did, didn't I? Yep. 123 degrees. So that's that angle right there. All right, so I've got 2 out of the 3. Now I can find the third one by what?
The same thing in the bottom.
Subtracting these 2 from 180. That's right, okay? So now, but I had to know angle 1, didn't I? So in order to get 3, I had to know what angle 1 was. And if I got angle 1 wrong, guess what? I'm going to get angle 3 wrong too, aren't I? So make sure you get that one right. So what's the math again? Now you could add them up and then take them away from 180. That's okay. There's nothing wrong with that. But this is doing the exact same thing. I think this is a little easier because you're just putting one thing in your calculator and you're not doing 2 separate steps. So it's 180 minus 123 minus what? 28. You see that? Took 180, took that away from it, and took that away from it. Let's do the calculator. So it's 180 minus 123. Oops. 123 minus 28. And I get 29. So that's what that angle is right there. That angle is 29 degrees. So there's my answers. There's that, and there's that. All right? So that's a nice example on how, what you're going to do, what the kind of stuff you're going to do, knowing that the angles add up to 180 degrees. All right? Let's move on. Let's do another type. This has a little bit to do, not a little bit, it's got quite a bit to do with what we just talked about. So I'm going to draw a triangle, but I'm going to extend one of the sides of the triangle. See that? So it doesn't just end right here. It keeps on going a little bit. And so I've actually formed an angle right here. That angle is on the outside of the triangle, isn't it? So we've used this word before. We don't say outside. What do we usually use? Exterior, right. So we call this the exterior angle of this triangle. Okay, that's the exterior angle. Everybody see that? So what do you think the angles inside the triangle are called? Interior angles, right? Yeah, they are acute in this situation, but they're interior angles because they're inside the triangle. What I want to do is look at this. I want to look at this angle right here and this angle right here because I'm going to show you. We have a little theorem, a little rule that tells us what we can do here. But I want to name these first. Do you see these 2 interior angles? They're the 2 angles that are furthest away from the exterior angle. Do you agree with that? Look at this interior. This interior is right next to it. It's adjacent to it. We've learned that word before. So this angle right here is close to this. These 2 are further away. Right? Well, there's a word. And you probably use this maybe every day. A remote control. Use a remote control, right? I know it's hard to believe, but I actually grew up back in the day before we had remote controls. And guess what I actually had to do if I wanted to change the channel? I actually had to get up off the couch, walk over to the TV, and actually not even just push a button, but it was a dial. You had to turn the knob, click, click, click. That's how old I am, okay? Didn't even have remote controls back then for anything, okay? I remember the first remote control I saw with a TV, it actually was to a cable box, and I was I grew up without cable until I was in college. I think it was the first time we had cable at our house when I was in college. So, but my friends had cable when I was younger. But they had a remote control, but it was actually hooked up. It was a wire that was actually hooked up to the box that was sitting on the TV. And the remote control was like this big old thing, almost as big as a keyboard. And you would actually, and to get the channels, you wouldn't like click, channel 1, 2, 3, 4, 5. They'd actually have buttons on this big old huge remote, a big gigantic remote. It was maybe about this thick and about this wide. And to get channel 7, you go boom, you'd find the 7 button and you'd punch 7 and you go to channel 7. Or you want channel 26, click, you'd hit channel 26. That's before cable even had like hundreds of channels. And that wasn't even my house. That was at my friend's house, and I thought that was the coolest thing ever. So anyway, my whole stupid story is because of the word remote. Why is a remote a good thing? Because what can you do? Do you have to be right next to the TV to use the remote? No, you can be what? Far away from it. Okay, that's what's cool about remote. You can be far away. So these two angles are called, what do you think? Remote, and they're what kind of angles did we say earlier? Interior angles. All right, these two right here are remote interior angles. So hopefully that dumb story about the remote control might make you remember. Oops, I forgot interior. Remote interior angle. All right, these two right here are remote interior angles. Well, we have a theorem that says this. It's a little wordy, but it basically says this. I'm going to write it down. That the exterior angle, I'll shorten it, the exterior angle, if I find out who's throwing the paper, I'm going to write you up, so you better not do it again. Okay, I've seen it fly twice from that general direction, and if I see it again, I'm going to write somebody up. So the exterior angle is equal to the sum of the remote interior angles. Write that down. The sum of the remote interior angles. That's our theorem. Well, what does that mean? Well, what does it mean to be a sum? Add up, right. So the exterior angle is equal to the sum, or if I add up the two remote interior angles, that's going to equal this exterior angle right here. Let's put some numbers in here just to make it a little bit easier to see. Let's call our exterior angle angle 1. Let's call this angle 2. Let's call this one 3. And let's call this one 4. Okay? So if I wanted to write up a little formula, right, a little equation, what would I write? The exterior angle. Which one is the exterior angle? It's angle 1. So I'd write angle 1 equals, now the sum of the remote interior angles. Sum means what do I do? Add them together. So what are they? Angle what? 3 plus angle 4. Notice I didn't put 1 equals 3 plus 4. I put angle 1, right? So you don't get confused between, 3 plus 4 is obviously 7, right, if you do the numbers. But this is just naming the angles. Angle 1 is the same as angle 3 plus angle 4. Isn't that saying the same exact thing as what this is saying? Yeah, absolutely. Now you know what they're going to do here, don't you? They're going to put some numbers in here and all that kind of stuff. So let's do an example with remote interior angles. Let me find a good one. They don't even give you any examples on this. Yeah, here's one. Alright, let's redraw the triangle again. Let's make it white. Hopefully you're writing this stuff down, are you? So this kind of looks like this and kind of looks like that. Alright, and let's put some, let's make this blue. Let's put some numbers in here and we'll see what we can solve for. This angle right here is 50 degrees. This angle right here is x degrees. We don't know what it is. And this angle down here is 2x minus 15 degrees. Yep. Alright, now, it's not just all straight numbers, is it? You're going to have to solve for x, aren't you? But what was our little formula? Our little formula was taking that exterior angle and then setting it equal to what? In this case, it's what? Give me the x plus 50. That's right. Alright, so let's set this up. If you go back and look at that little formula, do you see that? The exterior angle is equal to the sum of the remote interior angles. So that means in order to find this outside angle, the exterior angle, just add them up and set them equal to this. So we have to do a little algebra, don't we? Is this really any different than stuff that we've done in the past? Remember what I said? Every chapter doesn't necessarily get more difficult. It's just different stuff. You're doing the same math. Really, the math doesn't get any harder. You're really doing the same math, but you're doing it with different types of pictures. Would you agree with that so far? Yeah, and it's going to continue like that, really, the rest of the year, for the most part. So what do? We take that exterior angle, 2x minus 15, and set it equal to what? X plus 50. Because we take the exterior angles, the remote interior angles, add them up, and that's equal to this exterior angle. This is the one that's on the outside. Everybody got that? And now we just solve for x. We've done this dozens and dozens and dozens of times, haven't we? All right, with all your homework and your quizzes and tests and stuff that we did in class, you've done this a ton. So subtract x from both sides, add a 15 to both sides. 2x minus x is x. That's easy. That canceled out. That canceled out. What's that? 65. So x is 65, right? So if this angle right here is 65 degrees. I don't know if they asked this or not. No, they just asked. No, they do actually. Find this angle. Find the exterior angle. So what do we do to find this angle right here? Okay. Yep, you could do that. You could just plug in 65, couldn't you? What would be a little bit easier though? No, you don't even have to do that. Remember what our rule says. Our rule says what? That these two add up, right, to be the exterior angle. So in this case, it might be easier just adding 65 and 50. Wouldn't you agree? But you could do that. You could take 65, plug it into this, and get it. Let's try it both ways, though. All right? Let's just add up 65 and 50. What's that going to be? 115, right? So this angle right here should be 115 degrees. Let's do it this way and see if it works. All right? It should work both ways, shouldn't it? X was 65, so it's 2 times 65 minus 15. 2 times 65 is 130 minus 15. What's 130 minus 15? It's 115. You get the same thing, don't you? All right? And if you didn't get the same thing, you did something wrong somewhere, didn't you? All right? So that's how you get it. So it was kind of easy, wasn't it? Just adding the two together and finding what that angle is. Now, sometimes you got to read the question. You got to read the question on the homeworks. You got to read the question on the quizzes and the test. Sometimes they will ask you to find that whole entire angle. But sometimes they'll just ask you to do what? Just solve for x. Right. So sometimes they just ask you to solve for x, but sometimes they ask you to find a missing angle. On that quiz we just took, some people, it was like on the, I forget which one it was. Was it the one we just... No, maybe it was my other class. Maybe it was the honors class. But anyway, I remember recently they asked you to find like the length of the line segment. It was the honors class. They asked you to find the length of the line segment. You had to find what x was first. So I had a couple people just find x and left that as their answer. But the problem said find the length of the segment. Or this problem says find the measure of this angle. So you got to make sure that you read the instructions carefully, all right, before you do that. All right, so we good with that exterior angle thing? That's not too hard, is it? Let's do this, just for fun, right? Let's see if that whole adding up to 180 thing works. Let's find this angle. I'll do some different colors so it shows up better. Let's find this angle right here. This one right there. Now remember, we know this is 65, don't we? So we could do this a couple ways. You could just take 180 minus 115, right? But isn't that the same as 180 minus 115? Right? So if you add those up, that's 115, isn't it? Okay? This is 115. So do you see why you can just add these up and set it equal to this? All right? Because it works the same way. So what's 180? What's 180 minus 115? That's 65, isn't it? All right, so that's 65 degrees. Look at that. That's 65 and that's 65, isn't it? All right, it's not always going to be that. Okay, it's not always going to be equal to this angle up here, but that's pretty interesting. 65, 65, and 50, that's 130 plus 50 is 180, so sure, it all works out. It all works out real nice. All right, there you go. You could have done this if you wanted to. No, you couldn't have, not in that situation. You had to know that theorem on that situation. All right, let's do another thing. Let's talk about a right triangle now. We're almost done. Oops. Let's try that again. There we go. Is that a right triangle right now?
No.
Not yet, until we do what? The little box, okay? Or if they told us it was a right triangle, okay? But put the little box there. Now it's a right triangle. I want you to see this. Remember, if I add up all three angles, what are they going to add up to be? 180 degrees. If this is already 90 degrees right here, what do you think? Let's label this A, B, C. What do you think must be true about angle A and angle C? They have to add up to 90. Exactly right. Everybody see that? So angles that add up to 90, two angles that add up to 90 are called what type of angles? Acute angles. That's right. So here's a little theorem that says this, that the acute angles of a right triangle are they equal to each other? No, what did we say they were? This angle A and this angle C, they have to add up to be what? 90 degrees. What's the word for angles that add up to 90 degrees? Complementary, that's right. So the acute angles of a right triangle are always going to be what? Complementary. And that comes in handy a lot. For instance, let's say this angle right here was 30 degrees. Now, a lot of people will do this. Even in my honors class, I find kids doing this. I'm like, you don't have to go through that whole thing. Just realize that this angle and this angle are complementary. And they're like, oh, what? What are you talking about? All right, so, but you guys are learning this, so you guys can get this. So, look. So, to find this angle up here, we don't have to add them up and take them away from 180, do we? We don't have to go 180 minus 90 minus 30. Because if it's a right triangle, what's 180 minus 90 always going to be? It's always going to be 90, isn't it? So really, all I got to do is do what? One little math problem. Talk to me. 90 minus 30. That's all I got to do. Okay? That's as simple as it gets. So 90 minus 30 is what? 60. So this angle right here has got to be 60 degrees. Does that make sense? Now look, would it be wrong to go 180 minus 90 minus 30? Of course it wouldn't be wrong. Okay, but it's just one little extra step that you don't have to go through. All right? So these two angles are complementary, which means they add up to 90. So if I know one of them, I can find the other one just by subtracting it from 90. And that just makes things a little quicker, a little easier. That's the only reason that they even have that in there. Okay? Let's do one that's not quite as easy as 30 and 60. Let's do a right triangle again. Like this. Sorry, the triangle looks exactly the same. There's the right angle. And I don't know, let's do this angle right here. What if I said that that was 23 degrees right here? And I asked you to solve for angle A. And I said this was 23. One quick little, what's the easiest, most efficient way to find what this angle is right here? Say it. 90 minus 23. Okay? Is that the only way to find it? No. You could have gone 180 minus 90 minus 23. But what's 180 minus 90 always going to be? It's going to be 90. So why not just go 90 minus 23? Do you agree with that? And that is what? 67. All right. So now it's not exactly drawn to scale, but who cares? That's 60. That would be 67 degrees. All right. That's obviously not 23 degrees, but okay. Yeah, you've probably switched, right? But that is 90 minus 23, though, isn't it? Okay. Make sense? All right. We got time to do one more example. It's in the book, and then I'll give you a worksheet, and we'll be done. If you guys are writing this down, then you won't have a problem with putting your head down on the desk. All right. You writing this down? See, a lot of people just sitting there looking. Okay, I'm writing. You should be writing. Alright, that's what we have right there, and I'll put the angles in different colors. Go yellow. This is angle 1, this is angle 4, and I'll actually give you a couple minutes to work on it. See if you can do it on your own. That's 52 degrees. This is angle 2, this is angle 3, this is also a right angle right here. So it's a rectangle, isn't it? Everybody see that? And that's it. 1, 2, 3, 4, right? Alright, I'll give you a couple minutes. You got time. I'll give you about 2 minutes to work on this and solve for angle 1, angle 2, angle 3, angle 4. So you're going to have 4 answers here. Go ahead and start working on it. I'll give you about 2 minutes. right, that's enough time. Let's what do you want to solve for first? I think we can do angle 1, can't we? So let's do angle 1. I'm going to put angle 1 equals, and let's figure out how we find angle 1. This one right here. That's right, because look, I've got this right angle or this right triangle right here, don't I? Okay, so I'm looking at this little right triangle. I know one of the angles is 52. I know it's a right angle, so the most efficient way to do it is just what? 90 minus 52, which is what? 38 degrees. So that's angle 1. All right, I'm going to put that in there. That might help us. 38 degrees. Okay. Let's go angle 4. Even though it's not in order 1, 2, 3, 4, that's all right. Let's do angle 4. That's kind of easy. Since we just found this to be 38, then what's this going to be? It's going to be 52 as well, isn't it? Okay, because 90 minus 38. I just went 90 minus 52 is 38, so 90 minus 38's got to be 52. All right, so that wasn't too hard, was it? So that's got to be 52 degrees. Now, if this is a right angle, that has to be a right angle, doesn't it? Okay, so this is a right triangle right here. So look at this angle here, angle 3. So it's 90 minus 52. Well, we just did that. What's 90 minus 52? It's 38 degrees. Pretty simple, right? Seems like a broken record, doesn't it? Do you even know what a broken record is?
Yep.
Okay, so 90 minus 38 again is what? It's 52 degrees. So there you go. All right? And you can list them if you want to. Couldn't get any easier than that, could it? Pretty simple stuff. All right. You guys even know what a broken record is? Okay. Have you ever listened to broken records? or any to records, period? Have you? Okay. Good. Tell you what, there's going to be a day, not too long, that I'm going to have a class that they won't have a clue what I'm talking about when they talk.
I think it stands.
Okay. All right. I'm going to give you a worksheet, and then we'll be finished.